Yeah, everyone. No, hell no. I'm going to start asking it to edit for me because I am realizing I do not have it. I have my Chihuahua as my editor, and she's not a very good editor. So, yeah, okay. So with the books, anybody new people here, paper is yours, 3-ring binder is mine. So you can take this class, any other classes that are in there if you want. Okay. So we got a couple new people today. Where are we at? Oh yeah, we're actually after. Okay. Blah, blah, blah. Okay, so a couple of new people. Just so you know, basically what this is I've been doing technology since 1996. Weirdly enough, shipped off to basic March 20th back in 96, so like literally almost 30 years ago. I started doing YouTube videos for education back in 2009 after I shut down my business. And in 2009, access to technology education was very difficult, so streaming online education was a big deal. It is now 2026, everybody does that. And so my idea is, can we bring the lessons learned from YouTube basically into the real world? And so that's with Silicon Dojo. The idea is that this is just open education for everybody. If you want to show up, you come, you learn. If you want to leave, you leave. We are all crowd-funded, so my viewers throw money in. Many other people throw money in. If you go to silicondojo.com, you'll see this little donor box link up here. And we have some very generous people that throw money in to help fund all of this. So again, I come all the way from Asheville, North Carolina to do these. And yep. So yeah, so if you go to silicondojo.com, just so you know, this is our central landing page for everything. So we do use the meetup groups for RSVPs, but we are having multiple meetup groups now. If you come here, do be careful with the city. So we are starting Asheville classes again. So I'm from Asheville. So next week we're gonna have our first Asheville class in quite a while. And so you'll notice this is a class tonight. This is a class next week in Asheville. I'm doing a conference thing here in Durham. We're doing another thing in Durham. Then we're doing Asheville. Then we're doing Asheville. So if you like it, just make sure you know what city it's actually in. One of the things I will tell everybody is the job market, the job market is god-awful. So just so everybody, like, this is my real experience. This isn't me like on YouTube or whatever. So one of the things in Asheville, they're not really a big entrepreneurship startup scene. So I decided like, hey, what if we do fireside chats, but just for tech companies that are hiring people, right? Because it's more of an employee type deal. I figure this would be pretty easy. So one of the things I did is I contacted a founder that I know of a really good startup company. It's funded, it has employees, the whole 9 yards. They're looking for an employee. So I said, hey, April 14th, we're gonna do this event. Love to have you there. Are you willing to come? And basically said, Eli, I love the idea. But for the one position that we have open, we have gotten 1,000 resumes already, and we get 50 to 60 a day. So again, you talk about ideas not working the way you thought it was. I thought the fireside chat was going to be a phenomenal idea, and the reality is I may actually have to pull that simply because employers no longer care. They've got so many applicants already. So yeah, just go out there and schmooze. What's that? They had one role, got 1,000. And they were getting people from Google and Amazon and Facebook and the whole 9 yards. Yeah, it was brutal.
There's not a lot of tech jobs out in Asheville, right?
No, but it's a remote job too. And so, yeah. But I mean, that's the thing is like, you know, one of the things I try to tell people, because I've been a boss before, and one of the things I talk about is like when I used to put out help wanted ads, I get like 150 resumes. And I didn't know what to do with 150 resumes. Come on in. So I can't imagine what these employers are doing. Like you get 1,000 resumes in, like literally how do you filter through all that? So just something to kind of keep in mind. So take your boss an apple or something, I don't know. Oh, book for you. And I thought I knew you. I don't know you. What's your name again?
Andres.
Andres.
A-N-D-R-E-S.
Yeah, there we are. And here's one for you.
Thank you.
And your name is?
Andrea.
Andrea.
Yes.
Oh, crap. I got Andre. That's you, Andreas. And then you are, or did you sign up?
Oh, I signed up. Yeah, that's
Oh,
it.
Drea.
Mm-hmm.
Okay, there we go. Do you need pens? You got pens? Yep. Paper's yours, book is mine. So anyways, yeah, that is what the job market's like. The one thing I do tell everybody though, is the job market goes up and down. So my father actually retired from the government as a PhD safety engineer a number of years ago. And what nobody talks about is that when he graduated from college in the 70s, it was actually an engineering recession. Like you hear about STEM nowadays, everybody needs this. He literally graduated like the top of his class with an engineering degree and nobody cared. He literally went to work for OSHA because the government was the only one that was hiring. I had a buddy of mine when I was in the corporate world back in the 90s. I was literally making almost twice as much money as he was making. He was a manager at my company and I was a tech guy. I started talking to him. He had graduated in computer science in the 1980s. He became a manager because he could not survive off of the salary of a computer scientist in 1985. They weren't making enough money. So he became a manager, and then things changed. And then we had the dot-com boom, and then we'd have the dot-com bust. We had the boom before the Great Recession, then we had the Great Recession. So one of the things to think about is, again, if you care about technology, we do go through these waves. It sucks. I've been there. I have a story. You'll hear about it way too many times about I had my military experience. I had a college degree. I had my MCSE. I had 100 hours of telephone systems training. I had built out $500,000 data centers or server rooms. I literally at one point was in Seattle getting laid off of pizza delivery. You want to talk about your life being miserable. So, and things get better. Things do get better. So just one of those things just to keep in mind. So anyways, some things to think about with the job market. Let's see here. One thing, if you are here and you do care about networking and all that kind of stuff, there is the All Things AI conference, not next week, about a week and a half from now. It is something that you might think about going to. It's $200 for one day, $300 for 2 days with workshops. If you can't afford it and you contact them, Todd, the guy who runs it, he is the greatest guy in the world. If you say, please, 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 can I get in for free? He'll give you a free ticket, probably. So if you're interested in that, you might want to go there. And then the final thing, note is, so this is going to be the second to last class here. So this is very important. Again, we talk about locations. So this, American Underground, is moving to the Tobacco campus. So the Tobacco campus is literally like a block and a half that way. So we're gonna have this session here. We're gonna have the session on the 25th. That cybersecurity session will be here. And then when we go into April, classes will be over there. So just kind of keep that in mind. Okay, that's about what we got. Any questions before we jump into the class? No, cool. Okay, so we're going to be talking about Linux today. Exciting, exciting, exciting stuff. So basically the importance of Linux in the artificial intelligence world is that you get to build your own systems. One of the big issues that we're seeing right now with vibe coders is vibe coders don't know what the hell is going on, right? They type all this crap into to Claude Code or whatever else. They get this output. They post it wherever the hell they're supposed to post it. Oh, yeah. What's vibe coding? Okay, do you know Claude Code or these AI coding? Yeah. So what vibe coding is when people go to that and they say, I want a Salesforce alternative. And then it spits out a Salesforce alternative and they post that. So basically vibe coding is where you just tell the AI to create you an application and it creates an application for you. Yep. If you get lost in words or whatever, don't worry. So we have a lot of people that are vibe coding right now. The problem is, as I'll keep talking about over and over and over again, we as technology professionals do not get paid to code. We do not make real money for function calls or running cable or anything else. We make money off of this. This is worth hundreds of thousands of dollars a year. Writing function calls is worth a couple of bucks a year. And so the big thing is, I talk about architecture a lot, is how you're going to be designing these systems, right? Where are things going to be housed? Are you going to have your systems or your platform, is it going to be on a local server, sitting in a server room in your building? Is it going to be on AWS? Is it going to be on Azure? Is it going to be a hybrid cloud? What happens when something fails? There's all of these questions that come up. And so one of the big problems we have with the vibe coders is they're not thinking about that. They literally think that technology professionals get paid for writing code. So yay, I just got rid of my $150,000 a year tech employee and swapped it out with the $20 a month cloud account. And you're like, that's gonna be miserable at the end of the day. And so the big thing with Linux, right? So Linux is an operating system. So just like you have Windows as an operating system, Mac OS is an operating system, Linux is an operating system. It is the main operating system that people use for building infrastructure, basically because it's more or less free, right? You can, you can spin up a machine, a virtual machine, which is kind of like this cloud thing, or actually install something on bare metal, right? And it's not going to cost you anything. Basically, you just go to a place like ubuntu.com, you download the operating system, you install it, and away you go. And since it's free, and since it's something called open source, not only do people use it because it is free and open source, but then because it's free and open source, people start building on it. So it's like, do you want to build on something that's behind the Windows paywall, or do you want to build on something that everybody can get access to? So you have college kids building on it, and you have industrial people building on it, and the whole 9 yards. So when we talk about Linux, basically all this is going to be is an operating system, and the reason that this is important is it gives you flexibility in how you're going to be building your systems out. If you understand how Linux works, it gives you options. Let's see here. If we go to page 2, we have a whole bunch of warnings, because Linux does have warnings. The big one, especially if you come from the Windows world, one of the things to remember when you're dealing with Linux is not Windows. One of the biggest things is capitalization matters, right? So when you do Windows, file, 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 and file are all going to be the exact same thing in the Windows world. It doesn't matter. In the Linux world, all of these are different files. So if you try to access, right, the right name, but you put the capitalization in the wrong way, it can be a complete and utter mess. So to be careful about that. We talk about open source. So open source is weird. Again, I've been doing technology for 30 years. I still remember when people were arguing about this. So, and one of the weird things is this argument never really stopped, but people say it stopped, but it didn't. And so it's kind of going on in the background. And so we talk about open source. There's a concept of, is open source free? And so the question of free is, do we mean free speech or do we mean free beer? So when you go back to 2000 when I got my MCSE and NT 4.0, one of the big problems is we had no idea how our systems worked, right? I installed this thing called Windows NT 4 onto my server. I prayed to the spaghetti monster, and it may or may not have done what it was supposed to do. The problem was if there were vulnerabilities, if there were security problems, if there was any of that kind of stuff, we had no way of looking at the code and understanding what was actually occurring. We were just told this is how you use a system, and that's it. And so one of the big things, if we go back about 25 years ago with the idea of open source, is most of us, we weren't worried about money. We just wanted to see what the hell the damn source code was doing so that we understood how it operated and we could make any modifications if need be. We were fine spending $600 per server license with Microsoft, but if I needed to tweak something in the code, I wanted to be able to tweak something in the code. Anyways, so that's what we talk about when we talk about free speech. And then there's free beer, and basically free beer is the idea that open source should be free. And so there's something called the Open Source Foundation. Because their name is the Open Source Foundation, they just took this and ran, and they said, we are going to define what this means. And so now, theoretically, it's supposed to be free as in free speech and free as in free beer. So basically the idea is if it's an open source product, you should be able to use it freely, and you should be able to see what the actual source code is. But this gets really squirrely in the real world. One of the things to think about with open source is that there are many licenses for open source. There's something called the MIT license, the Apache license, a lot of different licenses. There's this stuff called copyleft and copyright and all kinds of different stuff. The big thing to just be thinking about whenever you're dealing with open source is just be careful. Free might not be as free as you think it is. One of the big things is like with Red Hat. So Red Hat is around here. Red Hat is a version, it's an open source Linux. But in order to get a lot of the things that you need to run Red Hat, you need to pay their maintenance contract. So to be clear, their software is open source. But the maintenance contract required to run their software is behind a $250 a year paywall. So you get into some of that weird stuff. So just kind of be careful. That's one of the reasons why I use Ubuntu. So everything we do here at Silicon Dojo is Ubuntu, because you just don't run into any kind of weird problems. Like it just works. You don't have to worry about licensing or anything else. We get to the whole idea is open source secure. So this is going to be one of the big lies that you hear is people say the reason you should use open source is because it's more secure than proprietary software, because you can see the source code, ergo anybody can read it and see what problems there are. Here's the problem. When anybody can read something, many times nobody does. There was something called bind, or there is something called bind within DNS. There was a flaw in bind for over a decade. There was a major DNS vulnerability that nobody repaired because nobody thought to actually look at it. Because it's DNS. Somebody obviously verified this crap worked properly. It didn't. So anyways, when you hear this thing about open source is secure, that is just absolutely and utterly incorrect. When we start talking about using Linux, one of the big things I'm a proponent of, and I've been a proponent of for decades at this point, is standardization. So there are a lot of different versions of Linux. We're going to talk about this. There's something called forks and distros of Linux. There's a lot of different versions out there. And somebody else, you can go have a beer and argue with somebody else about which the best one is. Again, we use Ubuntu here, which is a Debian fork. The big thing to be thinking about is in your environment is to standardize on something. I don't care what you standardize on something. Because Linux works perfectly 99% of the time. 99% of the time, this thing is going to sing, you're not going to have a problem, life is going to be great. And then it's going to fail, right? Here's the issue. There are many, 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 many versions of Linux out there. And so if you have 20 versions of Linux sitting in your server room, and you go down to sit in front of your server to repair the problem, what's the command for this one? Like, I've been working on this Linux box for the past week. I know everything in here perfectly. But literally, with different versions, there's different tools, there's different commands, that type of thing. You sit down at a different version of Linux, and all of a sudden, you may not know what commands you're supposed to use. So, like with Debian, like what we use, that's the fork for Ubuntu. Like if you want to install something, you use this command called apt install. And if you're in the Red Hat world, I still think it's that way, use a command called yum. So again, just imagine you sit down at a computer like, oh, I know what I need to do. I just need to install this application. You're like, crap, what command do I use to install? Like literally, that's the kind of level of stuff to be thinking about. So standardize, standardize, standardize. One of the other things to be thinking about when we start talking about Linux is there's this concept of total cost of ownership. So again, with Silicon Dojo, I always want you to be thinking about business. Think about this as a decision maker. Decision makers have to think about total cost of ownership. So the cost of the product is when you purchase Windows Server, it's going to cost you $600 for a server license, and then something called $50, or it might be $100 nowadays, for something called a CAL, a client access license. That seems like a lot of money. One of the things you need to be thinking about is what is the cost of your system going to be over the lifetime of the system. So that includes things like electricity costs, that includes maintenance costs, that includes support costs, and the whole 9 yards. It was very interesting. A lot of governments in Europe migrated over to Linux about 15 years ago because they thought Microsoft was too expensive, and they decided to go with Linux because it was cheaper. And a lot of them are rolling that crap back and going back to Microsoft because they found out it's actually cheaper to support $600 servers than it is to support free servers. Because with Microsoft, Microsoft has a lot of training programs out there, they have certification programs out there. Their systems have been around for 3 decades at this point. Almost anybody can sit down at a Windows server and manage it. If you have anybody sit down at a Linux server, it can be a bit of a disaster. So again, that's one of the things to be thinking about is like, what's the total cost of ownership for these systems? Maintenance contracts can be useful if you do decide to start deploying this into an enterprise environment. So you go back to your company, you're like, I really like Linux, but I am concerned that I am not a high enough level person to be able to support this in a disaster type scenario. A lot of the companies out there actually have support contracts. So Ubuntu, you pay them somewhere between a few $100 to a few $1,000s a year. And what's really nice is if you have a problem in the system, you can call them up and ask them, to help you with the problem. They can even SSH, what's called SSH is remote into your system. So they can even remote into your system and fix the problem for you. So that might be one thing to be thinking about if you're dealing with Linux. Let's see here. Beyond that, something to be concerned about with the Linux world is there's 2 major types of processors in the world right now. Basically x86, the Intel type processors. You'll hear about those. Those are the types of processors we've been using for a long time at this point. And then ARM processors. So if you're dealing with Mac, so this right here has an ARM processor in it. It has an M2 processor in it. If you deal with something called a Raspberry Pi, they also have ARM processors. When you go to install Linux, it's important to understand that there's two different processors that exist. So when you download the installer for the particular hardware that you have, make sure you download the appropriate version, whether it's the Intel version or whether it's the ARM version. So here, like I actually have virtual machines running. So this is Linux. Yay, exciting Ubuntu. Anyways, so this is a virtual machine. We'll talk about this in a second. This is a whole Linux operating system that's kind of running what's called an instance on this particular computer. The important thing to understand is I had to install the ARM version. So if you use something called VirtualBox or Parallels or VMware, you would download the ARM version and install it if you use something like a Mac. Something to think about. Let's see here. Exiting. This is going to be a big one. Getting out of anything. So anytime you're dealing with any kind of shell, how the hell do you get out is a big deal. And so these are different commands to try to get out of whatever the hell you're doing. Because again, Linux is one of those things. It's not hard, it's precise. It's not complicated. If you know what command to run, it works perfectly. If you have no idea what command to run, it's a rock. It's like that simple, right? So anyways, if you get into something, Control C, so like if you start pinging, if I start pinging, it'll ping continuously until I kill it. So you can do Control C, Control X normally gets you out of software. If you're using a piece of software like Nano, like a text editor, Control X will normally get you out of that. And things with text editors and some other stuff is if you do :Q, that might get you out of there too. So just understand if you get into an application and you're in Linux and you're like, I want to go home, and you're typing in all these commands and nothing's working, go to ChatGPT and say, how do I get out of this in Linux? And it'll say, type this command, and it'll get you out. So again, it's one of those weird things in life. And the final thing is generally when you're dealing with Linux, there's going to be two different versions. There's going to be the GUI desktop version and the server version. So what we talk about here is this is the GUI desktop version. And so basically, this more or less looks like a desktop that you're used to. It's not Mac OS, it's not Windows, but you're like, oh, it's got icons. You click on things, blah, 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 right? That is that. This is the server operating system, and that's what you get when you install the server operating system. You just get a blinking cursor. You either know the commands or you don't know the commands. Have fun. So what I would argue is for most people, what you should do is you should just start with the GUI, the graphical user interface, the desktop operating system. This will give you all of the functionality of the server. You can build web servers on here. You can build your bottle web apps on here. You can do everything you can. This is Linux. This is Linux just with a graphical user interface, what's called a shell. So it basically gives you all of the server components with being able to click and that type of deal. The other thing too is simple things like wireless internet, Wi-Fi, is very easy to deal with the graphical user interface. So basically you just, it'll automatically pick up the Wi-Fi for you, you plug in the information and it's no big deal. If you're dealing with the server version and you need to connect using Wi-Fi, you get to use a whole bunch of command line utilities and spend the next hour figuring out how to do that. So anyway, so if you start playing with this, I would highly recommend that you use the desktop version. And those oh, so this is, so I have, no. Yeah, so I'm, where? So this is, yeah, so this is Mac. So basically, I'm using VMware. So this is called virtualization. And so this is a Mac operating system. I'm using something called VMware Fusion. So VMware, they have Fusion or Workstation that's now free. And so basically these are 3 different virtual machines that I have running on this computer. So the important thing to understand with these operating systems is they're entirely self-contained operating systems, and so you can interact with them as such. So yeah, so we're using VMware. So yeah, that's when I'm swiping, so this is one desktop, this is another desktop, and that's a server, and so I can just scroll between those. Yeah. Everybody kind of get what's going on with there? Everybody understand virtualization to some degree? No. Yeah, that's going to be one thing too. Like as we go further into these classes, I talked about this in the TCP/IP class, the whole idea of logical devices and physical devices. So basically so this is one physical device here that then has 4 different logical computers on it. So when you're building out your architecture, it's like you design everything based off of the logical things you're dealing with, but all those logical things might actually end up being on one box. Okay, so let's see here. Why Linux for artificial intelligence? So basically, I was kind of talking about this before. The reason to learn Linux for artificial intelligence is it gives you options, it gives you possibilities for things to do. And then the other thing that you need to be thinking about is you need to be thinking about your architecture. So back in the old days, servers were very, very expensive. Operating systems were very expensive, right? So if I was deploying a server into my environment, it was going to cost, at least $10,000. When I talk about doing $500,000 build-outs of server rooms, in modern era, that sounds wow. But back then, it really wasn't that much equipment, to be honest with you. Like each one of the boxes cost like 50 grand a pop, right? The problem is the more functionality you have on one device, the more vulnerability you have on that device. So it's something called FTP, is File Transfer Protocol. It's how you transfer files around. It's great to have a file server, but FTP has vulnerabilities. If you have a web server, Apache 2 or Nginx, right, that is how you present websites to the visitor that's coming to your server. Those are great for doing that, but they have vulnerabilities too. And so what you want to do is you want to separate out all the different components essentially onto their own logical servers, right? So basically, like when we design our little AI projects, right, we're generally going to have a web server, and on this is going to be our Bottle web app framework, and we may have the LLM on there. So this is going to be one box, one virtual machine, one device, whatever else. But let's say we also need a record store. So we're talking about database, we're talking about SQL. We would actually want an entirely different SQL server that's entirely separated. We use something called firewalls to block what are called TCP ports, so that these computers can only talk to each other on those specific TCP ports. So if somebody compromises a SQL server, they don't also compromise my web server. If somebody compromises my web server, they don't also compromise my SQL server. On top of that, you talk about files. You may have a file server. Again, people are storing files here. You lock it down. Nobody's going to compromise that. And so the idea is that, especially with Linux, you can start building out all of these different virtual machines or boxes to do very specific tasks. This makes it a lot easier to administer. So again, if you're having a problem with files, I can simply go to this one file server and figure out what the hell's going on. Right? If everything is on this one machine and you start having problems, it can be a real bear to go through and try to figure out what's happening. If everything is separated out into their own machines, it makes it a lot easier to be able to deal with. And so that's one of the things with Linux too, is this is what I'm talking about, is it allows you to create much more complicated architectures for when you're designing your systems. And this is going to be important with artificial intelligence. Again, you're dealing with caching systems. We're going to have a class most likely in April on vector databases. And that's where I get frustrated with AI. Like there's this idea that this is AI. You need to learn AI. This doesn't mean anything, right? This isn't, right? So you're going to have some kind of user interface. You're going to have the way people are interacting with your system, right? That's going to come down, again, to some kind of back-end programming language. Again, under that, you're going to have your LLM. Not only are you going to have your LLM, if you listen to IBM folks, you're actually probably going to have a whole stack of LLMs on their own. Again, under that, you're going to have the files. Under that, you're going to have your record stores. You may also have something called caching mechanisms over here. And so this is kind of the idea of AI that we're sold, and this is the reality of AI. Right, this is how things are actually going to be working out. Let's see here. So when we talk about Linux itself, basically this is just simply an operating system. This is a lot of the stuff that we've talked about before. So a lot of people get confused. So they hear about Linux and they hear about Unix and they think, oh, it's the same thing. Linux is a free version of Unix. which is not the same thing, and it gets really, really, really confusing when you're a new person. Linux is its own operating system. Why people get confused between Linux and Unix is back in the day, there was this guy, Richard Stallman, we'll talk about in a second. He basically wanted to copy the functionality of Unix. So what he did is he wrote programs that had the exact same commands and the exact same outputs as Unix, but he wrote them on his own and he put that into Linux. So when you look at it, the way you interact with it is basically the same. The output that you get is the same, but you have to understand is the back-end operating system is an entirely different thing. Unix was created by a company called Bell Labs in the 1960s, I do believe, 1969, there it is. And basically what Unix was, is it was a mainstream operating system that was used on industrial equipment. So again, you think about the massive, you think about Bell Labs, right, the telephone company. This was the massive telephone switching equipment that they had when somebody made a call. It was the computer backend that could calculate where that call was supposed to go and route that call. So the thing was, it was incredibly powerful, but imagine if one company owned computers, essentially. And that's basically what you had with Bell Labs. Unix was the operating system that ran all of these major systems, and it was only basically owned by Bell Labs. So then we had this guy called Richard Stallman in 1983. He came out with GNU. GNU is not Unix. This is one thing you'll find out, again, if you're in the tech world for very long, is geeks have a horrible sense of humor that gets really confusing very quickly. So GNU literally stands for GNU, not Unix. Ha! Anyways, I guess it was funny in the 1980s. So anyways, this guy, Richard Stallman, he develops these Unix-like tools, and the idea is that they're free in an open ecosystem, and these got started in 1983. The weird part about this is, and again, this is also how the technology world works, is you'll notice GNU started here, and then we talk about Linux down here in 1991. He actually started building all these tools before he had what was called the kernel to actually build what we would consider an operating system. So he had all these tools, but he had nowhere to put the tools, essentially. So that's where you hear about this guy, Linus Torvalds, in 1991, when he was going to university, he came up with this thing called the Linux kernel. And it is important to understand, again, when you get to deal with geeks and they get a little drunk, this is obnoxious if you get into this argument. Linux, technically, is only the kernel. What the kernel is it's a low-level component of the operating system that essentially tells the operating system how to communicate with the hardware. How do you interact with RAM? How do you interact with storage, hard drives? How do you interact with networking? That type of thing. That's all it is. Literally, if somebody hands you a disk with a Linux kernel on it, it's a coaster. Most people literally, I couldn't do anything with just Linux. If you hand me the Linux kernel, I couldn't do anything with it. So basically, Richard Stallman and Linus got together, and it was like, hey, if we take GNU and we put that on top of the Linux kernel, then we have something that actually looks like an operating system, and we can move forward there. And so that's where you will hear some people talk about it's not Linux, it's GNU Linux. And it's also weird branding and marketing. Like most of you probably haven't heard of Richard Stallman, and most of you probably have heard of Linus Torvalds. And it is funny, like when you think about it, like they were both in this project, but people remember Linux. They don't remember GNU generally. So it's just kind of how it works out. So yeah, it was created in 1992 by combining the two things. Okay, so then we get to forks and distros. So Linux comes out, and again, Linux is free, open source, all the computer geeks are playing with it. The issue that you run into in this kind of world is people start building whatever the hell they want to build, and it starts getting wild really quickly. So the first thing that you start dealing with is forks. And so like with most of us nowadays, you'll be using either the Debian, what's called the Debian fork, or the Red Hat fork, right? And basically what this is you take the Linux operating system and GNU and all that, and then you have one group of people that says, hey, this is what we think Linux should look like. And we have another group of people say, hey, this is what we think Linux should look like. And so at very, I don't want to say low level, that's not quite right, but at very basic level, many of the basic tools that you will use in the different forks are going to be different. So again, if you go to install software on Red Hat, it is going to look different than installing software on a Debian fork, right? So when you're dealing with services like this, that's the thing, is services are, all the things that are kind of running in the back end to make the computer do what it does. And so Red Hat has their system for dealing with services, and Debian has their system with they both have services, but literally how you interact with those services are going to be different, right? So that's what we talk about with forks. Below that, you then get to distros, so distributions. And so when I talk about Debian, so Debian is a fork. And then here at Silicon Dojo, the two distros that we're normally going to use are either Ubuntu or Pi OS. So Pi OS is a Raspberry Pi OS. And so with the distributions, what it is basically you take that fork, those basic commands are all going to be the same, and then there's going to be certain tweaks that the different people are going to basically do to the operating systems to make them slightly different. So like if you use Pi OS, so the basic commands in Pi OS, like apt install is going to be the same. A lot of those commands are going to be the same. But with Pi OS, it has the device drivers and the configurations for dealing with what are called the GPIO pins. So does everybody know what a Raspberry Pi is here? Do you know what a Raspberry Pi is? Sort of? Little computer, yep. So Raspberry Pis are the little computers. They have what are called GPIO pins, so you can connect sensors and that type of thing directly to the computer. Plus you can connect cameras and other devices directly to it. So Pi OS actually has all of the configurations and all of the settings already in that operating system. So basically you can just install it and you can go away with it. So Pi OS is a distribution of Debian. Ubuntu is a distribution of Debian, the whole 9 yards. Everybody got that? Well. Then beyond that, again, this is where it starts getting, again, standardization, standardization, standardization. So then you have shells. So shells. So what shells are, shell is what you're actually going to be interacting with, right? So this is, I do believe this is the GNOME shell. It used to be Unity shell. So the shell is this kind of graphical user interface and the different tools that go along with the shell. There are many different shells that are out there. So that was the GNOME shell. That'll show you a little bit in the future. There's a shell called KDE. There's a shell called XFCE. There's a shell called Plasma. And basically these are just different environments you can use to interact with your computer. And again, so some of them are going to be different. Like I do believe XFCE is very lightweight. So an important thing to understand with any server, any system that you're going to be using, is the cooler and the fancier it looks, the more hardware resources it's going to take, right? So when I click on something, and you can kind of see, oh, come on. Cancel. So when I click on something, it's hard here, it's kind of quick. But like when you got the little transitions and the things going on, that actually burns RAM, right? That's using up CPU processes and the whole 9 yards. And so if you have something like a Raspberry Pi, or if you have another low resource computer, that can end up using all of your resources. So a shell like this can end up using a gig of RAM on its own, right? So it can be a big deal. So that's why there's shells such as XFCE. I think they use something like 25 megs of RAM in order to run. So it kind of gives you that graphical user interface, but it's not eating up all the RAM on your machine. And so it's just one of those things to be thinking about. Yeah, again, so KDE, I think, is one of the highest level shells. It uses a lot of RAM to run. XFCE is lightweight, and again, it looks like something from 1992, but again, it depends on what you actually need. The other thing to be thinking about with this is when we talk about shells, not only do you have the graphical shells, but it's hard to see here, but this is, anyways, PWD? Nah. Anyways, you can see that stuff up there. So this is a command line. So this is called the CLI, the command line. Can't really tell, it's hard to explain. This is actually using something called bash, it's called the born again shell. So this is actually a shell. So even the command line shell that you're interacting with theoretically could be a different shell. And this is, again, is where I talk about standardization. Imagine if you have 20 different servers all configured in 20 different ways and something goes boom and you have to fix it within 30 minutes. Do you really want to be messing with lots of different shells and things? Yes?
Is it easy to try a different shell? Like if I have Ubuntu with the KDE, can I try that XFCE easily? Any idea that I could?
Oh, yeah. I've played around. I mean, I'm not going to do it here. But yeah, just Google search or ChatGPT search. No, there's, again, it's SETI, so there's a command to install it, and then there's another command to flip, and yeah. Yeah, you can definitely play. That's also the nice thing with Linux, especially if you have a machine that you don't care about or like a virtual machine, is you can play with it all you want. You get tired of it and you just wipe it and start it again. You don't have to worry about license keys or any of that. That's a big thing, like for me, having done this for so long, is license keys used to be a disaster. You go back 20 years ago, man, you had to wipe and reload a machine. That wasn't a problem. It's like, oh, okay, this is gonna be 3 hours of work. Hey, yeah, just give me the license keys. I'll get right to it. What? No, where are the license keys? I don't know. And then you spend like 3 days like tearing through file cabinets trying to find license keys that people forgot about. Again, one of the reasons why Linux is very nice. So we talked about server. So whenever we talk about server or desktop Linux versions, the server is going to be that command line that I showed you. It's just going to be the blinking cursor, that's it. The desktop is going to give you a GUI of some sort. There is then going to be, like if you use Ubuntu, there's going to be LTS versions. So these are long-term support versions. So one of the things about with Linux too is everybody likes to play. And when they play quick, right? So there's going to be a lot of, like if you go to Ubuntu right now to download, you're going to see there's a lot of different versions of Ubuntu that you can download because they might be doing, they do different builds. Some of these companies actually do what are called nightly builds. The idea is they create a version basically every day. They let it out in the wild and see what the hell blows up. And then they fix the problems, release another version, fix the problems, release another version, whole 9 yards. So if you are going to be deploying into a production environment, there's something called the LTS version, long-term support. This basically means this is the version that is supposed to be stable. Like use this version if you're actually going to be using it on real servers. One of the big things is to look at how long they're going to support it for things like device drivers and that type of deal. So with Ubuntu, their LTS support standard for free is for 5 years. You'll get updates and all that for 5 years. If you pay, it can go up to 15 years. This can be significant because when you start writing, or when you start deploying these AI projects and using people's code, one of the big problems that we run into is ongoing maintenance of projects. So as these operating systems change, it's just kind of like your smartphone. You know how like every 3 months your apps tell you have to update, and you update it and it looks exactly like it did before you updated it? Same thing is kind of true in the Linux world, right? They update Linux, they change things, that type of deal. The problem is with open source, a lot of these projects people aren't getting paid for, and so they'll get around to it when and if they do. So they may have designed a stable version of something for, let's say, Ubuntu like 18. So Ubuntu's like on 24 right now. So their code works perfectly on 18. Past 19, it fails. And they don't care, they've moved on. So that's one thing where you may have to find an older version of Linux to actually be able to run the software that you need run. And then you have to figure out, is Canonical is the company that actually owns Ubuntu. You're gonna figure out how long they support it for. So again, that's the other thing with like costs and prices. You may say, well, I'm gonna deploy the server. It has service for free for 5 years, that's fine. But you go to deploy a piece of software, it needs a version of Ubuntu from 5 years ago, which means that service is running out. So then you may have to shell out $500 in a service contract to get support for that 5-year-old version. Again, that's the kind of stuff you get to with the Linux world. Okay, any questions with that kind of stuff? No? Cool. Okay, so when we're installing Linux, so there's a lot of different ways. There are a couple of different ways to install Linux. The first one is onto bare metal. So you're gonna grab a computer that's been sitting in your closet for the past 5 years. You're going to install Linux onto it. That is basically installing onto bare metal. So for Silicon Dojo, we have 2012 MacBook Pros that we use for lab classes sometimes, and you can actually install Ubuntu directly onto those machines. The big thing there is you're going to need to download the ISO file. It's called the ISO file, and then you're going to have to create a flash drive. So every operating system has a different piece of software to allow you to create a flash drive. If you click on this link or go to it, basically this is going to tell you how to create a bootable USB stick for Ubuntu, and you're just going to go through this process to create that stick. So basically I think you need something with like over 8 gigs of storage, and then you just kind of go through, okay, 6 gigs or larger, and then you go through and do all this stuff in order to actually configure it. So basically, you'll go through that process in order to install it on a bare metal. If you're going to install it onto a virtual machine, like I have here, so these are virtual machines, it's actually really easy. We'll probably have a class on this in the future. Where's my thing? So what's really cool here is, so this is VMware, so VMware Fusion. If I go and I hit this little plus button up here, I can do new. I can do install from disk or image. Hit continue. It's going to ask me for some stuff. We're just going to do live server. So we can do show in folder. So basically I've got these ISO files here. So we're going to do the server. Oops. Go back. Ignore. There, hit continue. It's going to give us some information here. So basically, you know, how much hard drive to give it, how much RAM to give it, that type of deal. And then you hit finish. Save as. Let's call it a test. And then now this is actually running in that virtual machine. Depending on how powerful your computer is, it'll depend on how fast this actually is. Again, this is an M2 Max MacBook Pro from about 2.5 years ago. So if we do install, I think this took about 2.5 minutes when I was installing it before. So it goes through, you can see all this stuff. It's going through this whole install process. And asks you English, what language you want. Layout. One of the big things, so whether you're installing the desktop version or the server version, do the search for third-party drivers. So again, we talk about that open source thing. One of the weird things in the Linux world, again, people think free is open source. Free isn't open source. It can be free and proprietary at the same time. So like this was a big deal, again, 15 years ago when Adobe was still a thing. Like so Adobe products were free. So Adobe Reader was free, Adobe Flash was free, but it was proprietary. You didn't know what was, and so many times Linux operating systems would not install Adobe products because they weren't open source. The issue that you get to here is that many drivers, although they're free, are not open source. So if you don't download the third-party drivers, when this thing goes and gives you that blinking cursor, not only are you just going to have a blinking cursor to deal with, but some of the hardware on the machine might not work properly, and then you have a nice, fun time there. So whenever you're dealing with this, you go here, you check off third-party drivers, and then you hit done. Continue. Yeah, I'll just do continue without network. Done. I'm just going to do this. It's going to ask you if you want to wipe the drive. So you say yes, you want to wipe the drive. So tab gets you to where you want to go. Done. It's going to give you all the information. You're going to hit done. You're going to hit continue. Again, if you don't click down to continue, it'll be no, and then it'll just keep doing your thing. You say user. So your name, what your name is, server name. So we'll call this server. Pick a username is user. Password is 123456. Password is 123456. Then we do done. Skip Ubuntu Pro. That's our own little maintenance contract thing. Hit continue. You're not going to do OpenSSH. Done. Continue. So now let's just go through. And in a second, about a minute, we should have an operating system. And so this is the other nice thing with these operating systems is, again, you can go through, you can mess with all the configurations, you can destroy everything, and then you can literally just delete the virtual machine that you have, recreate a new one, and it's generally no big deal. So, so this is taking a second. Okay, yep. So took that long, so we can now do reboot now. Remove, hit enter. So it's going to ask you to remove the USB drive and then hit enter. So make sure you hit enter or it'll just stay there forever. Yay, so that's an operating system. So this is a full-fledged operating system. You can type in user, type in the password. And yeah, we can see what our IP address is. We can see some different information. There's something called top, we'll talk about in a minute. So that is a full-fledged server, and that's basically how easy it is to install Linux. Unfortunately, with this one, I can't. So that's why the rest of this will be using the desktop version. Again, weird Linux quirks. Yep. But this basically just gives you the idea of how easy it is to install Linux. This is going to be one of the big things too, depending on where you are in your career, is install as much as possible. When I got my MCSE back in 4.0, back in 2000, one of the things is every time we came to class, we had to deploy our entire infrastructure over again. Like, so we had to install 3 workstations and our servers before we even started class. And one of the reasons that our instructors made us do it is they said, we want to make this so damn boring you don't even think about it anymore. When somebody says, can you install a server? We want you to groan. We don't want you to be like, oh, maybe I can. We just want to be like, again? Sure, right? So again, with this kind of building servers and things, like I'll get that, people ask me questions about like what my favorite like server build or computer build was. Like, I don't know. I've done thousands of them. I just build them. I can tell you my favorite clients or my favorite jobs, but you just build servers. So anyways, this is basically what you get at the end of the day when you install just the server version. Okay, any questions with this? No? Cool. So now let's go, if we're looking at page 6, let's just go to the desktop version because that is cooler. So this is the desktop version. Come on, give me my desktop version. So when you install the desktop version, again, this is going to look a lot like a normal operating system. Little light for you guys, but hopefully you can see everything. If you go down to the lower left-hand corner and click on this will show all of the different apps. So it'll show things like System Monitor, it'll show you settings, it'll show you additional drivers, or that type of thing. So this is something you might want to click on, especially if you installed the system onto bare hardware, an actual physical machine. Sometimes if things aren't working properly, if you click on the additional drivers, you'll see additional drivers here, and it'll tell you that you should probably install them. So that's something to think about. Beyond that, let's see here. If we go terminal, so terminal is the big one we're going to be using a lot. So this right here is exactly what I was showing you with that server, right? So this right there, this is the same thing. So I can hit top, and even though I've got colors and everything, I'm getting that exact same interface. So again, this is where I'm saying that if you're going to start playing around with Linux, go for the desktop version. Yep. No. So basically, and I might show it to you at the end. So basically what happens is you can install the server version and it's doing its thing, and then you can literally install, and I think it's Ubuntu-desktop, and it's just a package that gives you the desktop. Yeah, so this is basically with Linux. With Linux, it's how it was with Windows until relatively recently, where this kind of command line is actually how the computer works. And then the graphical user shell essentially interacts with that command line. So like if you remember way back in the day, they talked about that like with Windows 95 and DOS, where you actually had, DOS was actually running in the back, and Windows 95, that graphical user interface was on the front of it. So yeah. And so this is where I'm talking about like with the shells. So you could have the server, and then if you wanted KDE, so you wanted a different shell, you could install a different shell than this. This is what's called GNOME. So let's see, so there's that. Again, you've got a web browser. So this is useful for, again, with the GUI type thing, it's useful for when you're building your servers. So I created a service on this. We'll talk about that in a little bit. And we have something called Apache on here. So Apache is a web server. And so basically, the nice part about this is when I'm playing around, I can install the Apache server onto this machine, and then I can go to what's called a loopback address, 127.0.0.1, and that will show me the web page that my Apache web server is presenting. So I can use that all on this one machine. So if we go, I create a little service thing here called a dashboard. So this doesn't seem like a lot. It's just like a little demonstration. But basically what I have here is I have a continuous loop for CNN.com, and then it's writing the output continuously to an HTML file, and then that's being presented to us from Apache. So basically we are writing to a text file with a .html extension, and then Apache is able to present that to us as a web page, and I can test all of that within this one machine because I have this graphical user interface. Does that make sense? Let's see here. There are apps, so we can go here. This is the App Store. So there's software and updates. Nope, no, not that one. Go away. Where's my App Store? There is an App Store. I'm sorry, what's that? Oh yeah, if you go to AU basement, and then it's American Underground, uppercase A, uppercase U, all together. Oh, where is my, that's not right. Where is my app? They changed this since I was using it before. Software updater. Oh, I'm looking like an idiot now. Where's my App Store? Oh. Sorry, 1 second. Ubuntu App Store. Yeah, it used to be something different. Graphical user, open, and search for software. So with this, that. Checking for updates. I don't want you to check for updates. Sorry, they tweaked things. The last time I was using Ubuntu a lot was like version 22, and it's slightly different. Remind me later. Other software? No. Oh. App Center. Rebranded as App Center. Yeah, see, this is the thing that kills you. Okay, Ubuntu App Store rebranded as App Center. Okay, let me see if I can find App Center. God. Oof. App Center. Searching. Oh, Lord. Snap? Yeah, it's just Snap? So these things called snaps, that's its own deal. No.
I don't know.
Startup applications.
You just want to use the web browser.
Yeah, no, there's supposed to be this apps. Default apps. How do I get new apps? Oh, this is killing me. This is app stores. There we go. How do I get to my app store? Internet of Things. Did they change things? Install Linux apps using Snap Store. All right. Wow, I get to feel like a fucking idiot right now. Okay, there is an app store, just like there's an iOS app store and there's a Microsoft. I swear to Spaghetti Monster, it exists. They changed whatever the hell the location is. So if you want to install VS Code, so like VS Code is the IDE that we use, you can install VS Code directly onto your Linux machine and use it for writing code and that type of thing. I'm just not sure where they hid that. Anyways, let's see here. Beyond that, if we go up here, we click on this. This is going to give us some options up here. So this is going to show us things like our network connection. We can click on the gear, and this is going to give us a whole bunch of other stuff. So this will give us all of our networking information, Bluetooth, things like displays, basically the size of the display, sound, power, again, all this normal stuff. And that's going to be the big thing when you're dealing with Ubuntu, the desktop version. If you look at this, this has all the stuff that Windows or Mac has. It's just going to be in a slightly different version. So anyways, that's a bit of a demonstration of this. Is there any questions? No? Cool. Okay. Let me see one thing here. Control C. Let's make sure of something. Okay. So the next thing to think about with Linux is SSH. So this is going to be one of the ways that you're going to be dealing with Linux. If you take a look at page 6, it's called Secure Shell. So you're going to be using SSH generally. So like if you go to DigitalOcean, so when you're thinking about Linux, Linux can be in any number of places. It can be on a bare metal machine. It can be in a virtual machine. It can be up on a company like DigitalOcean. They have virtual machines up there that you can rent for anywhere between $4,000 to $5,000 a month, that type of thing. And basically you're going to be interacting with them using something called SSH generally. And so what Secure Shell allows you to do is it allows you to connect to the remote Linux box basically with an encrypted connection so that you can run commands and install things and that type of deal. Basically, it uses port 22. Again, so we did the class on TCP/IP before. So there's something called TCP ports. It's going to use port 22. So do be careful with your firewalls. If a firewall is blocking port 22 and you try to SSH, it's just not going to work. If you do try to connect to the system, one of the big things is that the SSH server does have to be installed. So again, especially if you're installing it on a local machine, SSH server might not actually be installed already. Basically to install it, you do this command, we'll talk about this in a second, sudo apt install, open SSH server, and that's going to install it for you. Basically from there, what you can do is you can go to a terminal. So whether you're on Mac OS or whether you're on Windows or whether you're on Linux, you can run this command, SSH, what the username is at either the server's IP address or the domain name, right? So if I show you this, let me go to my terminal. Clear. So, okay. So hopefully it still works. So, okay. So again, we got to go logical. We're going logical here. So I'm on my Mac operating system, and I'm trying to connect to my Linux operating system, although they're on one box. I know. I will get injured in order to teach all this. So just so we know, logical. So this is physical, but logical, what's going on, right? So this is on OS X. So what you use is the command SSH. We do the username, so the user that I'm trying to connect with at, again, whatever that IP address is. So this IP address comes from here. So the IP address for the Linux machine is 10.255.2.179, right? So when I'm here, I'm going to connect with user at 10.255.2.179. I hit enter. It's going to ask for the password. So this is the password of that machine. Yay. And so now we'll see user at desktop, and we see all of this. So I am now in that machine, right? So I can do, ls-l, let's say clear. Clear. So I can do ls-l. And so this is showing me all of the files and folders that are in the directory for that user account on that remote machine. So this is how we can interact with it. So this is basically all we're talking about with SSH. One of the cool parts with SSH is with VS Code. So again, our IDE. So our IDE that we use, again, is VS Code. So this is some code we'll talk about in a little bit. One of the cool parts is there's actually an SSH extension for VS Code. So with that extension, what you can do is you can actually connect to that remote server in VS Code, and then you can start creating scripts there, modifying scripts, being able to interact with the system directly through VS Code. So that's one of the things that can be done with SSH. Does everybody kind of get what's going on there? Yeah. Cool. Okay. Now the next thing to look at, if we're looking at page 7, is sudo. Super user do is what I call it. I guess everybody has their own appropriate way of doing this. So one of the things you have to be thinking about with these systems is, again, the whole concept of security, of what happens if your system gets compromised. So a lot of versions of Linux, when you create the initial account, when you're setting up the account, you're going to have a user named root. And so the user named root has access to everything. It owns everything on the system. here's a problem that you run into. It owns everything in the system. So you're sitting there, you're typing away, you're doing all this work. You realize, oh, I need a cup of coffee, I need to go to the bathroom, I need to go to lunch, and I forget to log out. I forget to log my system. And then the Zimbabwean hacker that snuck into your company comes up to your computer behind you, and now they are able to do whatever the hell they want on your system, right? That is a bit of a disaster. So the idea with sudo, so this is one of the things that's really big in the Ubuntu world, is that when you create the user account, in order to actually access things at the root level privileges, you have to write the sudo command, and then you have to put in your password in order to be able to run something. So if I want to do sudo apt install nginx. So basically, nginx is a web server. So I'm like sudo apt install nginx. Hopefully, I've timed out. See, what it's going to do is it's going to ask me for that password first, right, before it allows me to do that. So there are some of the Linux versions out there where it won't ask you for the password. You can just automatically do whatever it is you want to do. The other thing to be careful about, again, when we talk about distributions and different configurations, is so this is standard for Ubuntu, and it's been standard for Ubuntu basically since the beginning of Ubuntu. But you go to DigitalOcean, and DigitalOcean wants to do stuff the way DigitalOcean wants to do stuff. And so even though you're using Ubuntu on DigitalOcean, they actually create the account as root, and you don't have to use sudo there. So one of those weird things. So basically, if you're doing any kind of administrative tasks on the system, you'll have to type in sudo, and then you'll have to type in whatever your password is, and that should allow you to do the things. One of the things you do have to be careful about, though, is there's certain things, you get into this with like Python modules, which can be a real big problem. So when you're using sudo, you're now at that root level, root permission level. So you have access over everything. So if you do sudo python 3 space -m pip install blah, whatever the module is, it's going to install that under the root permission level. When you normally run your Python scripts, you're not running them at the root permission level, they're running at your permission level. And so you can get these really weird problems where when things like, if you install Python modules with sudo, sometimes you'll get weird conflicts because the way it was installed doesn't work with how you're trying to use it. So that's going to be a weird thing. There's also some other weird stuff with sudo, so just kind of one of those things just to keep in mind when you're doing this. Again, once you start playing with Linux, you'll start ripping your hair out pretty quick as you understand what's going on. And that's the basic idea with sudo. Any questions there?
So you don't install it as sudo, you just install like your regular user permissions level?
Yeah, so like when you're doing Python, so yeah, so like when you're using pip with Python, you don't use sudo, you do Python 3 or pip install, yep. Because yeah, you can run into some weird issues. Okay, let's see here. Let me go over to the other system. There you go. See, this is the nice part about virtual machines. I can just go over to an entirely different. So we were on that system. So now we're on this system. So just we're all clear here. Okay, so this is a pretty clean machine. I literally installed this right before you guys came to class. So this already has, as I say, this already has a lot of stuff installed onto it. So we're going to go over to this, where this is a cleaner machine. So when you first install everything, not everything is going to be up to date. So one of the things you want to do is, you want to run the command sudo apt update. So one of the cool things with Linux, since we don't have to worry about licenses, right? We don't have to worry about all those fees. They started creating what are called repositories like 20, 30 years ago. Basically, the idea being is, hey, what if we just had a place online where all the installation files were, and you can simply access it and be able to install it and not have to worry about anything. So Linux has actually had these app stores, or the equivalent of an app store, for 3 decades at this point. So what sudo apt update does, you have to run this first, is this goes and it updates all the information from the repositories to make sure your computer knows where everything is stored. So you hit enter. Again, it asks you for the password. And it's going through, and it's basically fetching all of that. So it's like, okay, so now all the repositories are up to date and knows where everything is. Then, if you want to actually do the update process on your computer, sudo apt upgrade. So what this is going to do is this is going to install all of the updates. So the first thing you have to do is you have to update the repositories, and then you actually do the upgrade. Again, this one I already did, so it goes that quick. If I hadn't already updated the system, it's probably a couple of gigs worth of data that has to get pulled down, so it'll take about as long as that takes on your particular system. So that's how you upgrade the system. Past that, then you can actually install an application. So again, what's really cool here is sudo apt install Apache 2. So, okay, so when I do this, so I'm going to open up Firefox, my web browser, and I'm going to go to what's called my loopback address, 127.0.0.1. I'm going to hit enter, and it's going to fail out, unable to connect, because I do not have a web server yet installed onto this machine. What's really cool about Linux is sudo apt install Apache 2. So Apache 2 is a web server. I simply hit enter. I say yes. It goes through, it downloads, boom. We come back here, and literally, bite me. Hold on 1 second, sudo service. Sorry, what's that? 127.0.0.1. Yep. HTTP. Oh. Okay, ooh, there we go. I forgot the HTTP, I guess that. So anyways, so literally, by simply running that one command, I now have a full-fledged web server running on this machine. And again, especially for a lab environment or for a test, you can now start building web pages, actually be able to access them, and the whole 9 yards. So that's basically how easy it is to install things in Linux. Yep.
So how is that different from what you were trying to show us before, the apps?
Okay, so the apps, so this is the repository, again, for like the server, all the like the command line tool. So again, if I can figure out what the hell the App Store is. If you look at the App Store, it looks like a normal App Store. You go to it, it has search, you do install, it's very graphical, it's pretty, it's, yeah. So this is gonna be like when you install Apache, when you install Python. So if Python isn't installed, if you need to install pip, again, these
Things are in the app store.
yeah. So the App Store is going to be for like any of these graphical kind of apps. Again, VS Code would be installed through the App Store. Python 3 would be installed through the repository, that system. Oops, what's that? App Center, is it now App Center now? Oh, is that, all right, well, maybe let's, okay, is it App Center? Yeah, this is the big thing with in the computer world is they just like to rename things. App Center? App Center? Yeah. I don't know. Well, no, this is the desktop version. I don't know, the utilities. This is killing me here. Fonts. Anyways, clocks, app. Yeah, I don't know. Something for me to figure out. Okay. So then beyond that, so that's basically how you're able to install an application. If you want to remove the application for any reason, it's sudo apt remove Apache 2 or whatever the name is. The important thing to remember with that though is it does leave all of the configurations. So that can be useful. Remember, any application that is on your system could be a vulnerability. So let's say I know I want Apache 2 to be running in a little bit. Maybe I can pull it off the system, leave all the configuration files there as I do other stuff, then reinstall Apache and all the configuration files are there. If I do purge Apache 2, that will wipe the software and it will wipe all the configurations that I put in. Yes?
I was wondering, have you ran into any apps that aren't compatible with ARM? Because that was a concern I had. Like, you go to install software and they don't have an ARM version.
No, well, again, and I will caveat this, as an education person, everything that I'm trying to teach you folks is very standardized, so I'm not trying to go outside the lines. So I haven't run into it yet because I think most of, again, Apache, Nginx, Squid, that's all gonna work fine. I think where you're gonna run into issues, if you try to use any proprietary software, you might run into some problems there, so, yeah. It's kind of one of those that there might be issues. Test, 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 test. Yeah. Okay. There we go. Cool. Any questions with that? No? All right. So if we go past that, we go to page 8 and we get to Nano. So basically what Nano is Nano is a text editor. So you get to the Linux world, people get very picky about their text editors. If somebody starts arguing with you about a text editor, walk away. What? No, they are stupid arguments. Anyways, there's V, there's Vim, there's Emacs. What I'm going to be showing you is Nano. There's a whole bunch of different ones out there. I like to use Nano because it is dirt simple. Yeah, like you don't get lost. Because like I used to use Vim. So 15 years ago, Vim was my favorite one. Literally, in order to use Vim, I had to have like a cheat sheet right beside my computer just to know all the commands in order to get anything accomplished. What I like about Nano is basically things are on the screen, and I'll show you that here in a second. So what I can do is I can do sudo nano. So again, I'm calling this particular tool, and then I want to create a file. So var www html and then hello.htm. So basically what I'm doing here is sudo super user do nano, that is the text editor, and then this is the file. So this is the file path. So when we installed Apache 2, it created the folder www and html within the var directory. Basically, anything within the HTML directory is something that you can access from the web browser. So what I'm doing here is I'm now creating an HTML document called hello.htm. That's basically what's happening here. So I can hit enter, and it brings this up, right? And so the nice part here is it gives you some things to know what you're doing: help, exit, write out, read file, where is, replace, cut, paste, execute, justify, some of this basic stuff here. But what I can do is I can go up here and do h1, hello world. And so again, if you know HTML, I'm just saying hello world. We're creating a nice little hello world script. I can do Control X, so that's going to be exit. It's going to ask me if I want to save. I hit yes. It says where do I want to save to? It's going to be that. Enter. And then I can go here. And now I can do hello.htm. Hello world, yay! So that's basically how you use Nano to go in and you can edit files. So one of the big things in the Linux world, especially with a server, is all configurations are going to be in text files. So whether you're using Apache or Nginx, you're creating services, anything else, there are these really god-awful, ugly text files. And so basically you have to go in there, and if you want to change things, you literally have to use Nano or one of these text editors to go in, modify settings within the text file, and that's what will actually change how the server function works. But that's the basic idea of how Nano works. Any questions? No? All right, cool. Then past that is services. So again, one of the issues you run into, if we take a look at page 8, again, in the Linux world, there's lots of different ways to do things. And unfortunately, they change things even when other things are working fine. So there's a tool called service, and there's a tool called systemctl. Apparently, service is old, and systemctl is new and better. I have been informed because I read about this. For you as a normal user, it probably doesn't matter, right? So service was what was being used all the way up until a couple versions ago in Ubuntu, and now they're trying to move everybody to systemctl because it's the cool new thing. The thing to realize, at least right now, is that both of those tools actually function. So like I can go here, so let's say I'm having a problem with my server. So for some reason, again, let's say Apache 2. Let's say I installed Apache 2 and things aren't working properly. One of the things I can do is I can do sudo service Apache 2 status. And so this will tell me the status of Apache 2. So this is going to be big. So anybody that did the bottle class, I don't know, Herman, did you do the bottle class? No, you weren't there. Anyways, so once we start actually doing the classes where we start deploying things, so with bottle web applications or with Django, we're going to have a Django class in the next couple of months. When you actually go to deploy the web application, you have a lot of different services that have to come together for everything to work properly. And so one of the big things is simply using the status command to figure out what service is failing. Like literally, so see how it says active, it says green active, so I know this is running. So if I come here and the service isn't running, then I know there might be a problem. One of the big things, like if I want to stop the service, again, I can do sudo apache 2 stop. Now when I go to do status, we can see active, so right now it says inactive dead. So if I'm like, why is my Apache 2 not working? It's because the service isn't even currently functioning. Again, to get out of this, I do Control C, because that's how I'm getting out of this. One of the big things to realize too, one of the ways you're going to lose a lot of your hair in this world, is in Linux. What's very important to understand is when you modify configurations, those modifications do not take effect until you restart the service. So when you go into futz with Nginx or Apache 2 or this thing called Squid or anything else, you're going to sit there, you're going to spend an hour typing up these beautiful configuration files. You're going to save, you're then going to go use the service, and it's not going to do what it's supposed to do. And you're like, crap! And you're going to go back and you're going to edit the configuration file again and again and again and again for the next 4 hours. Until you realize, Eli said something about restarting the service. You restart the service, and that's what loads everything into memory, and now your new configurations are actually working. So remember, whenever you modify a configuration file in Linux, restart the service immediately after, because those configurations are not loaded until you restart the service. And so all you have to do is, again, like Apache 2, you simply do restart. Yay! That's what will save you a lot of your hair. So anyways, that's basically what's going on with services. Again, so you can either use systemctl or you can use service. I use service because I've always used service. Again, technically systemctl is supposed to be better, but I couldn't really tell you why from a practical standpoint. One of those weird things. Any questions on services? Yeah, cool. Okay, then we're going to go to page 9, security, users and groups. So this is going to be a big thing with whenever you're going to be dealing with Linux machines. So basically when we talk about security, it's what permission do you have to interact with something? So with Linux, so if you're dealing with a Windows world, Windows now has like 50 different levels of permission. It's absolutely insane. In the Linux world, it's only 3. It's read, write, or execute. You can either read a file, you can write to a file or delete the file, or you can execute. So basically be able to execute a script. Those are your basic abilities. And then you have, for everyone, for the group owner, or for the actual owner. So everyone is everybody. Anybody that's able to connect to the system by hook or by crook is able to do whatever that permission is. Group owner is you can have groups, and then you can put users into those groups. So the group owner, so you put the user into the group, and then the group has a certain permission. And then the owner, that's an individual user account, and that's what permission they have, right? And so basically through all of this, you figure out what permission somebody has to interact with something on a Linux machine. One of the big things, especially with artificial intelligence or these IoT projects that we're going to be doing, is essentially everything on the Linux server is basically a file, like a file object. So if you want to give your script permission to use the web camera, there's actually a video 0 object that you would give a group a permission to be able to access. So basically with it, what you would do is you would put your user account into the group that owns the video, and then that would give your user account the permission to use the video camera. So whether you're using microphones, video cameras, any kind of hardware on the machine that you might have to have permission to is basically just like a file. Let's see here. When you're logged in, one of the big questions might be is, who am I? Again, that says user, but it just shows me, okay, I am actually a user. So I know what user account I'm logged in as. This is going to be a big thing, again, when we start talking about permissions and actually deploying things into a production environment. Different user accounts should have different permissions on the system. So you might have to modify configurations in one user account, swap to another user account to do different configurations, swap to a different user account to do different configurations, and you might lose track of who the hell you are, and you might start running into problems because you don't have the right permission level. So simply doing who am I shows you who you are in the system. If you want to take a look at the settings for all users on the system, sudo cat etc passwd. So basically, again, everything is stored in a text file. The cat command is basically a way that you're able to just look at what's in a text file simply within your command line. So when I take a look at this, this shows me all of the different users that are on the system. And you'll notice there are a lot of, systems that, or users that are created by default. So you have the root user. So the root user shows you different information. It shows you where their home directory is, essentially. If I go down to www-data, so whenever you're creating things for web applications, for Apache 2, you may want to give the www-data, that user account, permission to the file or folder. And again, you can see this is where the home directory for www-data is. And somewhere down here is going to be user. Here's my little user account, and it shows that my home directory is a home user. And so basically these are all the different user accounts on the system, and these are generally being used by services to do specific things on the system. This gets a little bit confusing at the end of the day. It's one of the things you'll learn more of. It's kind of hard to fully explain. What's that? Oh, yeah. They mean something. I forget what they mean. Well, with all of it, it's definitely useful. If you need them, they're useful. Let's see here. If we want to go through and we want to do something like add a user, it's pretty simple. So you simply do sudo add user test user. This is how I could add a user to the system. Hit enter. New password 123456. Pat is shorter than, okay, anyways.
I think those are user and user group IDs.
Oops. Hold on one second. What's that?
I think those were user and user group IDs that were showing.
I think it was something like that, but yeah, I have to go back to, yeah. It asks you for things like full name. You don't have to put that in there. Room number, work phone number, basically different information you can put in there. Is this information correct? Yes. Then it added it. We then go to show this again, and we now have test user down here, and it shows us the home directory. So that's basically how you're able to add a user. You can create a group. So again, groups that I kind of talked about before is sudo group add, and you can add a group name. If we want to take a look at the groups themselves, you do sudo cat etc group, and this is going to show us all of the different groups. So we can take a look here. So under ADM, we have users, syslog and user are under that particular group. CD-ROM, user is under that particular group. Sudo, So it shows you the users that are in particular groups. Users, test user. So this basically shows you the different groups that are there and the different users that are going to be in those particular groups. Let's see here. Yeah, this is just a lot of tedious stuff, but we got to go through it. Let's see here, clear. Okay, so ls-l is how you list files in a directory. So we can do ls. This will just show you the files just that way. If we do ls-l, that shows us the files and the folders here. And then this shows us the permissions over here. So here we see read, write, execute. So everyone has read, write, execute. Doesn't seem right. Oh, I'm feeling like an idiot today. Read and execute. Group user. Must be the other way. It is the user account has read, write, execute permission. The group has read, execute permission. And everybody, wait a minute. Yeah, with those days. So the user account has read, write, execute permission. The group owner has read, write, read, execute permission. And everybody has read, execute permission. That seems weird. Anyways, it shows us permission. Let me show you something here. Oh, you ever had one of those days? Touch, test, file. Yep. Okay. So I created this. So this shows you the different permission levels. So read, write, and read. So those are there. Oh, I'm fucking this one up. Anyways, let's see here. What this shows you, so it shows you the permissions, and then it also shows you the owners. So this is the user account owner and then the group owner. If you want to be able to change that for some reason, you can change like the owner. So let's see here, sudo, change own. Yes. So basically using this command, so sudo change owner. So you say who you want to change the owner to, and then the file that you want the owner to be changed to. And now you can see before it was user, so individual user, owner, group owner. Now we have down here, the individual user owner is now www-data, and the group owner is user. So that's basically how you're able to change owners. Let's see here. If you want to change the permissions to a particular file, so let's say a text file, you'd use the change mod command. So let's say sudo change mod 777 text. So as you saw before, this was like read, execute, read. So by doing the change mod 777 text file, what this did is it changed the permissions for the file. So it changed it for the user, the group, and for everybody. Basically, when you start looking at those numbers, if you look at page 10, basically 1 is for execute, 2 is for write, and 4 is for read. So if you do, let's say I did 1 here. Yeah, okay. So basically what we can see is read, write, execute, read, write, execute. That is only execute because that was 1. If we do 3, so if we do execute plus write, we do 3. we will now see before it was just execute, and now we have write and execute. Then if you want to go for 4, we then see it's now read. And basically that's how you just keep going up. So then if you go for 5, so 5 would be read and execute. So again, now you have read and execute here. And then 6 would be write and read. And see, now you see I have write and read. And then that's where you go up to 7. And then that's basically what's called full permissions. And you have read, write, execute. Does that kind of make sense? What's going on with those numbers? Yep.
What does it mean to just have execute permissions without read?
So like a script could fire off.
So you could run the script, but you couldn't see what's in it?
Yeah, so let's say you want, again, like when you think about like service level accounts, you might not want them to go to read or something, but let's say, would that work? Basically, if you wanted the script to fire off, so if the script would fire the command. Yeah, that's where it gets into permissions. So I'd have to think about this very carefully. So basically, you have the ability to fire off the script. And so the script could do whatever it has permissions to do. So the script might have permissions to like read from a file and go to a folder or something like that.
Based on its owner or something.
So when you fire it off, it will be under your permission level. It should be under your permission level. So let's say you have a script that's able to, let's say, read from websites and then dump into a particular file, so it could do that kind of thing. That's where it gets a little weird with permissions. That's where I realized today I should have boned up more on teaching you folks permissions. This does get a little confusing to actually teach. So basically, it would be firing off, it would be running under your permission level. So whatever your privilege level has access to, it would be able to access. So again, like REST API calls, it should be able to do things like REST API calls and anything within your computer that you would have access to. Does that make sense? Yeah. Ugh, I hate privileges. I hate security. Anyways, so that kind of gives you an idea of what's going on with that stuff. Yep.
Like the DRWX, I know
Yeah.
D is directory. What are the 3? It's like user group.
So yeah, so it is owner, so the user owner, the group owner, and then everybody. Everybody. So like when you go to so yeah, let me show you. So something real. CD bar www HTML. All right. Yep. So basically, this is what's sitting in the Apache 2 directory. So that's that web server that I created, and that's that HTML file. So basically root, so it's root is the owner, root is a user owner, root is the group owner. So there's a root group. And so since I created it with Sudo, right? So root has read write permission. So as root, I'm able to edit the file and view it. The root group is able to just read it, and then everybody, again, and so we talk about everybody since it's on web browser, everybody is able to read it. So I wouldn't want to give everybody the ability to write to it. That could be a problem. Yeah. All right. Any other questions? No? Cool. Okay, then let's talk about directory structure. Yeah, get away from security for a second. All right, where are we at? Where are we at? Oh my golly, 8 o'clock. I really actually tried to make this a short class tonight. Oh, I am bad at creating short classes. Okay, so The first thing is PWD. We'll show you what current directory that you're in. Again, one of the big things, especially when you start administering systems, is knowing where you are and who you are. So PWD is going to show you where you're actually at. So this is showing me I'm in the var www HTML directory. That's really easy. Again, LSL, as I showed you before, will basically show you, it lists, basically it's like the dir command in Windows. It'll list everything for you. It'll show you permissions. It'll show you the owners. It'll show you the last time the thing was modified, that type of deal. Let me do something here. CD. That's home, right? CD home, CD user. Yeah. ls.l. Okay. So I go to, so I'm now in my home directory, and this shows me the folders that are in my home directory and that file that I created before. One of the big issues that you run into in the Linux world, though, is you have hidden files. So you may not see the hidden files. So if you add a, so basically ls space -l space -a, that is going to show you all of the hidden files that are there. And so these may be configuration files. Again, when you're trying to actually modify files and you're trying to figure out where the hell the file is, you might have to use the a argument in order to be able to see those files. In order to change folders, so you can see we have folders here. So if I want to go to, let's say, the desktop folder, I simply do cd and I do desktop. So one of the things to remember in the Linux world is it takes everything literally. Right, so notice I don't have any slashes before desktop, right? So I'm here and I want to go into desktop. You can now see that I'm in, well, hopefully you can see that I'm in desktop. If I do ls-l, now there's nothing actually there. So basically I'm now in that particular folder. The thing is, if I try to do, let's go back up. So if I do cd .. /, that's going to take me up one level, right? So if I do, pwd, see I'm now in my user directory again. So lsl, right? I've got my desktop. So if I'm thinking I'm in the Windows world and I do /desktop, what you have to understand is how Linux is going to look at this. The /, what this means is the root directory, the root of the entire system. So it's going to go back to the root of the entire system and try to find the desktop folder. So when you try to do that, it's going to fail out because in the root of the system is not desktop. So you can either do cd space desktop or cd. And so this is going to be one of the things you see in code a lot of times. // means from this directory, go one directory down. This is called a relative path. And that will now get you into desktop. So that's going to be one of the things to be thinking about when you're trying to change folders. Again, if you want to go up like 2 levels, so you can do cd ..wa .. So when you do that, each one of those is taking you up 1 level. And I can do ls-l from here. Oops, ls-l. And then I can see the different user accounts that are there. And this is the basic way that you're able to navigate through the system. Again, it's one of the important things to understand with Linux. Don't have to be smart, you do have to be precise. Yep. Oh.
I've always used the .. Is there a difference between .. and .. Yeah.
I've always used .. / I don't know, is there, can you do ..
You could just do cd space ..
Well, look at you. I guess you can. Again, there we go. Again, Linux world. 50 ways to do the same thing. I've always done .. / so okay, new thing to learn. Let's see here. Okay, so we're going to change directory. I want to go to home, and I want to go to user. So I'm now back in my user's home directory. If I want to make a directory, it's simply mkdir, and then new directory, and that's how I make a new folder. I simply do ls-l space l, and then I now have my new directory folder. That's basically all you do to create a new directory. If you want to move files, this is going to be a big one. So to move or to rename files in the Linux world is the same thing. So basically we have like this text file down here. So if I wanted to rename that, I would do mv text file to, I don't know, new file. So basically what you do is you simply say what you put in what the old file name is, you put in what you want the new file name to be, and that is how you both move or rename the file, right? So new file is now there. If I wanted to actually move it somewhere, I would do mv, I would do new file, space, and then desktop / new file. And again, this is where people get into trouble, and they think you have to be smart, but again, you have to be precise. So I have to type this properly. If I do this, that's how it's going to get moved, right? So if I do cd, you can see that the file was moved, but since I fat fingered the name, then the name isn't proper, right? So again, that's one of those things you have to consider whenever you're doing Linux. And again, you just have to be precise with what you're doing. If we go up one level, we can see that that file is no longer in that directory anymore. Again, it got moved. So mv either renames or moves the file. Be very careful when you do it. Copy, so basically cp. So there's a command called touch. File. Basically what touch does, again, Linux has all kinds of weird commands that seem very bizarre until you actually need to use them. They're like, oh, that's smart. What touch does is it literally just creates a file. It either creates a file or changes the modification time of the file. So if I simply do touch file, that now exists, right? So that's, again, we'll get into this more when we get into programming, that touch actually has a value. So all I needed there is I needed something to be able to play around with. So I now have a file name called file. So if I want to copy that, so I can do cp file, another file. So basically I'm just copying. And so this is going to be big for those configuration files. Remember, all the configuration files are going to be text files. So before you start fat fingering those damn things, copy a version. And so that's where you'll see a lot of times people will do like, they'll have the configuration file and then it'll say .back, B-A-K. That is the backup version of the file you're futzing with. So that if you completely screw things up, you delete the file you're dealing with, just simply take off the .back, and now you have your configuration file again. LSL, and so now we have both file and we have another file. All right, that's all a copy is. Remove, if I want to get rid of a file, RM a file, LSL, whoops, the hell, LSL, and now the file is gone. Oh, that's me, the fuck. I have no idea why I have an 8 o'clock alarm going off. One of the things you'll notice as I'm doing all of these things is you'll notice it doesn't ask me whether or not I actually want to do this. As soon as I hit enter, it happens. Again, be careful with that with the Linux world. I've talked about the story before. I had a buddy of mine. She was working 100-hour weeks. Literally, she was doing a database migration from one old database server to another database server. This contained our entire CRM solution for a 9,000-person company. She literally was so tired, she basically did the delete command on the brand new server, right? She was supposed to delete the old server because the old server was done and to retire it. And she'd been working on the new server all day. So when she did like the remove command, she removed the new, and literally she fat fingered it, screwed up the command, and it failed. And she was like, oh. And then she fixed the command and wiped out her entire new server. And so yeah, that again, that's one of the things to be careful about in the Linux world, because as soon as you hit enter, it is done. Again, if you want to delete a folder, rmdir and the folder, that will remove the folder. If there is stuff in the folder though, you do rm space -r and what the folder is, and that will delete the folder and all of its contents. Let's see here. I'm getting pretty close to the end. Okay, let's see here. Cat and writing to files. So this is something that can be useful, just so you know about. So if you want to do a command and you want to write it to a file, again, for a lot of the code that we're going to be doing. So ping is a command to reach out and touch another server, see if it's actually communicating with you. So let's say we want to ping cnn.com. One of the things we can do is we can simply use the arrow key, and then we can do result.txt. And so what that's going to do is it's either going to create a file called result.txt or overwrite the file called result.txt. So I want to do that. It pinged cnn.com. Whatever the results came back, it dumped it into that file. So this could be useful for creating log files. So if I do, let's say cat result.txt, I can see what the results were for that particular ping command. If I want to append to that particular file, let's say ping space c1 fox.com. If you do arrow arrow result.txt, it will then ping fox.com, and when we do cat, it will have the information both for pinging cnn.com here and for pinging fox.com here. So this is a way you could run a lot of commands against your system, dump all of that into a text file, and then be able to process that text file later. So that's basically how you're able to write to to files and the cat command. You can also use grep if you want to get specific information. So okay, so ping space c1 cnn.com. So when I do this, this is going to provide a lot of information back. But let's say I only want certain information, especially for, let's say, the Python scripts that I'm doing. So if I look at these, I can look for specific words that are on lines. And what the grep command does, it says only return the lines that have this specific word in it. So if I do the ping command like I did before, I do the bar, I say grep, and then I do RTT. So basically, let's say all I want to know is the speed. So this is what's called the latency, the speed. I want to know what that is. Basically, what grep allows me to do is it then only provides me that particular line coming back. So that can be a useful thing. Any questions there? Well, all right. Past that, you have things like your IP address. So again, especially if you have your server, this is going to be an important one. IP is the tool for dealing with your IP address. If you do ADDR, this is what's going to give you your IP address, your different IP addresses. So this is your loopback address right here, 127.0.0.1. And then here is, this gives us what our actual IP address is. Again, for anybody that was in the TCP IP class, you'll notice this is a /24, so it has a class C subnet. So again, like if I'm trying to interact with this from the outside world possibly, I can use that particular address. So like with this particular server, all right? All right, so, Control C, Control C, Control X, there we go. Okay, so I can do, so I see here, this is my IP address, 10.255.2.179. So in this virtual machine, I've made it so this machine is actually active on the overall network. So 10.255.2.179, 10.255. 10.255.2.179. There we go. Okay, so again, we're doing this whole virtual thing. So now we're in Mac OS. So Mac OS is looking at the Apache server on this Apache server. So again, I can go to 10.255.2.179. If you can see, this is Safari. So this is on my Mac computer. And I'm able to pull up the website that is on my Linux machine, right? And so basically using that IP ADDR, that's a way that you can actually get the IP address to know what you're dealing with. That's going to be a big issue. Once you start dealing with systems in the real world, there's something called DHCP, Dynamic Host Configuration Protocol. When you connect your computer to the network, you will automatically be given an IP address. The problem is you will not automatically be told what the hell that IP address is necessarily. So you might have to go find it. And so that's one of the ways you can do that. Let's see here. Go back to this system. One of the things you can do is IP route, just kind of showing you some different commands here. And what this is going to do is it's going to show you what your default gateway is. So 172.16.216.2 should be your default gateway. So your default gateway is the router that is going to get you out of this particular network. Again, this goes into TCP/IP, a class we did before. Okay. Oh, let's see here. Then we've got other stuff we can do. Let me do this. Sudo apt install PHP. So PHP is a back-end programming language for being able to build dynamic web pages. One of the problems you run into, though, is that you need to find the php.ini file. All right. So basically, when you need to configure PHP, there is a text file that you're going to need to configure, and the whole question is, where the hell is it? So there's a command called find. So if you do find, right, that's a command. Then from find, you then say, where do you want to start? So basically, if you do /, that means start from the overall system root directory, because I have no idea where the hell php.ini is. Then what I can do is iname. Because one of the issues is I don't know what the capitalization is. Is it uppercase php.ini or lowercase php.ini? So if you put in name, so if you put in /name, it will leave the capitalization as you give it. If you put in iname, it'll mean the capitalization is whatever the capitalization is. And then from there, you put what you're looking for. So php.ini. So that's what I'm looking for. I can then hit enter, oops, and it's failing out because I didn't do sudo, sorry. So find, sudo find. All right. So this is then going to tell me where the php.ini files are. So etc php 8.3 Apache 2, there's a php.ini file, and under CLI, there's also a php.ini file. So again, if I'm looking for something, again, there's something called squid. Let's say I install squid. I'm trying to figure out where the configuration file is. You can use find in order to do that. The important thing here is you want to use sudo if you're logged in as the administrator, because you know that whole read, write, that whole thing? If you don't have permission to read a folder, you can't see whether or not a document is in the folder. So especially when you're looking for configuration files, you want to use the sudo command to make that work. Beyond that, you can use wildcards. So the star sign or whatever basically says any character, any number of characters. So I hit enter. That will give me all these different, so it starts with PHP dot, and then I have all these other things, ini-development, ini-production. Again, it's basically a wildcard thing. If you use the where is that? Oh, if you use the question mark, that gives you a single character match. So if I did like, I don't know, I guess. Again, it gives me the same things. So the question mark here, where did I put the question mark? Oh. Question mark here basically says any character, one of those characters, right? It's basically just that wildcard thing, where if you're trying to figure some things out. And again, this is where you're going to get into with programming and system administration, is you'll notice the syntax is different things use different wildcards. And so a lot of times it's just knowing what this particular system requires as a wildcard. There's grep. I showed you grep before. Let's see here. Then there's top. Top is going to be useful, especially when you're using low power systems. So let's say you use DigitalOcean and you want to deploy an AI solution on DigitalOcean and you wonder why the hell everything's going to crap. Basically, all top is this is an activity monitor for Linux, right? So here it tells you what the total uptime is. So how long has this system been up for? How many users are logged in? And then this is average load. And so what this is saying for the CPU is how much CPU utilization has there been over the past minute on average, past 5 minutes on average, and past 15 minutes on average. So that's one of the big problems you run into when you're trying to troubleshoot systems is it's fine when you look at it. Like your users are complaining and then you log in and everything's fine, right? So here, basically there's no utilization here. But then you look at the 5 minute mark and the utilization is through the roof. And you know, oh, okay, there's some kind of weird problem going on there. And that's where there's something called cron jobs. We're not going to get into tonight. Cron jobs are where you can automatically set tasks to fire off. So you might have a task that fires off, let's say every 5 minutes. And when that task is running, it uses 100% of your CPU. But then as soon as it stops, it goes away. Well, anybody trying to access your system while the CPU is getting pegged out is going to have a lot of problems. And so it'll be like a weird thing to try to figure out. Here it shows you CPU. It shows you how much percentage of the CPU that's being used by the user, percentage of the system the CPU that's being used by the system currently, and the amount of CPU that's currently idle. So you can see 99% of the CPU is currently idle. It's not a big deal. Down here, it's going to show you how much RAM there is. So again, this is going to be a big problem, especially when you deal with Linux machines. Because again, if all you've got is the command line, you don't have any of the graphical stuff, you have some box that somebody set up 20 years ago, and it just keeps running, and you have no idea how much RAM is in that system. Does it have 2 gigs? Does it have 1 gig? Does it have 50 gigs? And so by coming here, basically what you can see is you can see the total amount of RAM. So I can see for this particular system, this virtual machine, I gave it 4 gigs of RAM. I can see currently 168 megs is free, almost 3 gigs is used, and 1 gig is being used for the buffer over the cache. This is going to be a big thing when you're using the LLMs. So when you're using the LLMs, the entire model has to get loaded into memory. So that's going to be a big issue, especially if you're using something like DigitalOcean. So basically, if you've only got, let's say, 4 gigs of RAM, and you have the operating system running, then basically you can only use an LLM that is smaller than however much RAM you have left, basically. Something to think about there. Past that, this then shows you the different services that are currently running. It shows you how much CPU they're using and how much memory, the percentage of the memory that they're currently using. And so you can see what's going on there. Again, pretty basic stuff. If you want to kill a process, so basically that PID number, you can do K is going to ask you what process you want to kill, and we're not going to kill any processes because that would cause issues. But let's say your script, again, let's say we created a script, it's running, it's causing havoc. This might be a way to try to kill that process, basically a force quit of the process. What's that?
How do I know what service PID is?
Okay, so, oh, wait a minute. Where is my,
Is there a way?
normally it says, preferences. Oh, Lord, you ever have one of those days?
Oh, it's okay.
Yeah, normally I remember seeing that.
Is it a UI or
Yeah. There is a way to see the name. I need to scribble. Show name. Okay. Anyways. So that's there. Okay. Let's see here. Then past that, Control C. The next thing is UFW. So UFW is called Uncomplicated Firewall. So this is basically a software firewall for your system. And this is where I talk about when you're setting up this infrastructure, right? Every network communication using TCP/IP uses a TCP port. So again, SSH uses port 22. And so basically what you can do is SQL, I forget exactly what port it is, like port 483 or something like that. What you can do with UFW is you can say, I only want this computer, so 192.168.1.55. I only want this computer on this port to be able to communicate with this server. So if any other computer tries to communicate with this database server, the connection will simply fail out. And that's basically what you're able to do with these firewalls. We're not going to settle with firewall today. It's its own thing. One of the things, though, again, if you look at status, sudo UFW status, if you're running into problems with things like SSH or any other types of connections to your Linux box, make sure that the firewall is in fact turned off so that you know that's not causing the problem, right? Because if the firewall is on, it might cause you issues. That's the other thing to be thinking about with security. A lot of times people turn on security first. Like they say, I'm going to go secure first and then build everything. The problem is as you're building things, if you screwed up your firewall rules, nothing is going to work properly. So it's better to make sure everything works properly and then turn on your firewall rules to basically secure everything down. If you take a look at page 14, basically it shows you, sudo UFW enable allows you to enable the firewall, disables the firewall. And then basically these are some different commands here. So sudo UFW allow 22, basically that will allow SSH to work, right? Sudo UFW allow SSH, so it knows what that particular service is, so it'll allow port 22. Sudo allow UFW allow from 192.168.100, so that will allow communication coming in from that particular IP address. And this basically gives you some of those ideas of how UFW can be configured. So again, it's basically just a thing for the firewall. The final thing here is mounting drives. So again, when you use the GUI, the graphical user interface, this is going to work basically like Mac OS or Windows does. You plug in a thumb drive, it will mount, you'll be able to get access to it. An important thing to understand, if you're using just the server version, you plug in the thumb drive and then you have to manually mount it. There's a number of commands you have to do. I'm not going to go into them tonight. But in order to access that thumb drive or in order to access the additional drive, you actually have to mount it. Now, when you mount it, that's not a permanent mount. As soon as you reboot the system, that mount is going to go away. So there's certain configurations that you have to plug in to permanently mount that drive going into the future. Again, it's just one of those things. One of the reasons why using the GUI is a lot easier. Yep.
It's also something you have to do using cloud machines and you mount volumes.
Oh, yeah, yep. Yeah, so basically, like, not just, so more or less, the Linux box is going to see a thumb drive as like any hard drive. So again, let's say you have a physical desktop machine and you have like 5 different hard drives in there. You would have to mount all 5 of those hard drives for them to work. Or again, if you're using a cloud system and you connect storage in some way, that's also going to have to be mounted. And again, that gets into its own. We're probably going to have a full day Linux administration class when I have rethought how I teach permissions again. But anyway, so that'll be coming in the future. Okay, any questions up till there? No? Okay, getting about to the end then. So the final thing here that I want to talk about till we get to the labs is services. So this is where this particular thing is working. Okay, so basically what a service is in the Linux world is this is going to be something that you want to auto start essentially when the computer starts. So again, this might be valuable for AI processes. Let's say you want to grab log files and dump them into a database, be able to do this type of thing automatically. So what I have here is basically what I have is a service that I created. All this service does is it automatically writes to this dashboard.htm file, and what it does is it automatically writes whatever the ping return is from pinging CNN.com. So the nice part about this is whenever I reboot this computer, all of this will automatically start on its own. I don't have to manually start it. Basically, if you take a look at it, oh, where did I do? Let me scroll back to the command. Oops, sorry. Hold on one second. Okay, so I do sudo slash etc slash systemd slash oops. System slash, I think that's my app dot service. Oops. Yep, okay. So basically if you look at the top of page 15, what I did is using Nano, I created this particular service script. And so I called it my_app in order to create it. And this is basically the information that you put in for the service. So up here, you put description equals, and then you put whatever you want the description to be. Now this isn't important, this after equals. So network.target, what this means is do not start the service until all of the networking services are up and running. So especially if I'm doing something like the ping command, what will generally happen is the computer will try to start the service 3 times, and if it can't start the service 3 times, it'll just fail out. So if the service is trying to ping something, right, if networking isn't functioning, it is going to ping while network isn't up, it's going to fail, fails once, fails twice, fails 3 times, fails out. So basically what this after is saying, what do I want to wait for until the service starts? Under here, user equals, what user account do I want this to run under? And again, this is where we get into that whole permissions thing. And this is where we can have 20 different user accounts on our systems to do different things for different services. So I'm just having this run under user. What my working directory is, so basically where should this fire off? So var www.html. And then what this is here, so this is a Python script. So app.py is a script. And so what I'm doing here is I'm calling the Python interpreter, but I'm using the full path. So /user/bin/python3. This is where the Python3 command actually resides. And I want to give that full path so I don't get something wonky going on, right? So basically this is calling Python3, and then with Python3, I want to start running this particular script. That's what happens here. This can also be for anybody that's been working with Python. If you have a virtual environment, if you have this full path to the Python value in your virtual environment, that's the virtual environment values would go there. Under here, restart. Again, if it fails, should it restart? You say always, and then basically wanted by multiple users on the system. So basically, when you write all this properly, hopefully your script is going to fire off basically whenever the computer is rebooted. If we do Control X, so we do, let's see, nano var www html /app.py. So that's the script that I created. Again, if you don't know Python, this is pretty simple. So we're going to import the OS module. So while true, so this is going to continuously loop. Response equals os.popen ping --c1cnn.com read. So this is the module, this is the function. This function says fire off this command on the operating system level, and then whatever the value is, assign it to the response. And then with open, dashboard.htm, write, so overwrite as file. This right here is basically an HTML. This is an auto refresh. So what it's saying is on its own, automatically refresh every 5 seconds, and then write, and it pre-formats the response that comes back. And so this is what gives us that pre-formatted response, and this is what gives us the ability for it to automatically refresh. Basically, if you go down and you look under reload services, enable services on restart and start service, basically sudo systemctl daemon reload, what that does is it looks for all the services in the directory and basically reloads all of them, right? And then system enable my script service, so whatever the script name is .service, that means it will run when the computer starts. And then start the service, so that's where you start the service. So basically reload all the services to make sure the computer knows that they all exist. You enable the service so that it starts on restart, and then you start the service so that it's actually functioning for you. Any questions on that? Oh, cool. To shut down the computer, you do Linux reboot. To reboot the Linux, sudo reboot. And to shut down Linux, do sudo power off. That's how you shut it down. You can also do shutdown, but then it waits like 2 minutes before it actually shuts down for some weird reason. So power off shuts down the computer immediately. Okay, any questions on everything I've shown you up to this point? No? Cool. Okay, then we'll actually go to some scripts to kind of show you some interesting things you can do with Linux and an LLM. Okay, so basically we got 2 scripts here. One of the things we're going to do is we're going to process top, and the other thing is we're going to process ping. And this is kind of adding some AI functionality. So one of the big things we need to be thinking about is in the modern world, we fetish-size data. For about the past decade, there's been, like, until AI is the new oil, right now AI is the new oil. Yesterday, data was the new oil. I don't know what happened to data. Anyways, we've been collecting lots and lots and lots and lots of data. And one of the big problems we run into is even for technical professionals, we don't necessarily know what the hell we're looking at. Like, what are we looking at? And so the idea here is with this particular script is we're going to use the top command. And once we pull in the values from the top command, again, that activity monitor that I showed you before, then we can ask the LLM questions about what the hell is going on with our computer. So this is actually going to be running on my Mac operating system. So Mac is actually a Unix operating. This is Unix. This is one of the only Unix systems you're ever going to see in your life. Anyways, since it's actually running on this machine, I have to use a specific command for Mac. So this is the command for Mac OS. This will be the command for Linux. And again, you'll notice that they're very similar, but slightly different. So for Linux, you have to put the -b, -n1, where for Mac, you put -l1. Again, it's just those, again, and that's the type of thing that I tell you about, is like these small, imagine you're trying to fix a problem and the CEO is screaming at you, and you're trying to figure out, do I put in -b or -l, right? Anyways, so basically, what we're going to be doing here is from Ollama, import chat and chat response. So for any new people, we use the Ollama LLM framework, allows us to run LLMs directly on my machine. We're going to import the OS module. And then command equals this command. So basically what we're going to be doing is we're going to be pulling in the value from the top command. And then what we're doing here for head space -n30 is I'm limiting the value that comes into only the top 30 lines. Again, if you want to hear a very expensive computer get very loud very quickly, when I pull in all the values from top, this thing grinds. Like, I have never heard it so loud in my life. So we're just going to pull in the top 30 lines, so hopefully it saves this poor little computer. So what we're going to do here is response _OS is going to equal OS popen, that command, and read. So bring in the value, read it into text, and then save that as response _OS as the value. We're then going to go down here, so that's my AI function. We're going to go down here, so our while true loop. So query equals input, so this is where we ask our question. Response equals AI, the response OS, the value that came in from top, and what the question is. Then we're going to print out a line, And then we're going to print out what our query is and what the response was. Oh, yes, see ya. If we go up and we take a look at this AI function, basically it's all pretty simple. So if you've been dealing with Olama in our classes before, so we're going to say answer in under 50 words to keep it short, answer this question, whatever the query is, from this data. This is the response from top on this machine, so the response OS. So this is going to be the new query. So the query comes in here. We're then going to modify the query. And then we're going to send that query to GPT OSS. So this is the model that we're using. Again, when you're using models, I love Granite 4. I love the small Granite 4 models, but they're not necessarily the best models in the world. GPT-OSS, it is OpenAI's open source model. It actually works well. Oops, before any more people leave, I have to take pictures. No, people left without the picture. If you don't take a picture, it doesn't happen. There you go. Yay. Sorry. Okay, so basically we can now run this. It's going to bring in the values from top. Okay, so I can ask it a question. Let's see, how is my computer doing? And now we do a little dance. Do a little dance. I don't know if it does. Well, no. Okay, so when this runs, so top is running before the query runs. Your machine is healthy, CPU is idle, approximately 81%, load averages, blah, 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 memory largely free, 31 gigs used, but it says 31 gigs of my memory is being used. So I can say, what is using the most RAM? Uding. Thankfully, I can understand my horrible spelling. The largest resident memory consumer is the com.apple.webkit using about 169 megs of RAM. And so basically this kind of gives you the idea of how you can use an LLM to kind of go through and look at a log file and try to get an idea of what's going on. Let's see. How could I make my computer faster? Fatter. Oops. I'm a horrible typer. Your system is memory bound, has a lot of background work, close unused apps, reduce services. Anyways, some basic stuff. So again, think about this if you're pulling in like log files for security or something like that. This gives you a little bit of a way to try to start interacting with that information. Any question on this kind of thing? No. Cool. Okay, then the final one, the final little lab we have is a ping lab. So it's a lot like the last one, slightly different. So basically, we import from Olama chat and chat response. We import the OS module. And then what we're going to have here is we're going to have these different websites we want to ping. So CNN.com, Fox.com, and TacoBell.com. So query equals input question, site status equals stats. So I have this stats function here, and then I'm going to submit the site list. So basically when we take a look at this, all I'm going to be doing is I'm going to create basically a log file for site in the site list. Response equals popen, ping the site. So basically what's going to happen here is we're going to ping CNN.com, and we're going to add that to the log. Then we're going to ping Fox.com, we're going to add it to the log. We're going to ping TacoBell.com, and we're going to add it to the log. And then we're going to return that entire log value. So we're just going to ping those sites. So again, imagine if this is in a production environment. Let's say it's Salesforce, and whatever your CRM solution is, whatever your QuickBooks solution, you ping all those things, and then you can start asking questions about why there might be problems. Basically here we have response equals AI, so site status and whatever the query is. And again, basically the same thing. Answer this query from this data. This is the response from pinging sites from this machine. And then we have the response there. Okay, so. Yeah. Okay, so when we run this, all right, so it's gonna, question down here. How is the internet? How is the internet? Internet appears healthy. All 3 pings succeeded with low latency and no packet loss. The local host ping confirms loopback functioning. Again, there's a problem I had with Taco Bell. I fucked with my host file like 3 years ago. I still haven't fixed it. So I was like, why can't I get to Taco Bell? Why am I having problems with tacobell.com? Hit enter. So your machine's host file maps tacobell.com to 127.0.0.1, so all traffic goes to your local machine. Right, so again, I'm able to ask these questions in a very natural way, right? You know, how fast is the connection to CNN.com? Connectin. I am horrible at typing. The ping shows round trip of about 9.7 milliseconds to CNN.com, indicating a very fast connection. So again, imagine, let's say we're doing VoIP. Is the connection to Fox.com good enough for VoIP? Yes, 11 millisecond ping and 0 packet loss indicates low latency. So with voice over IP, you need a latency of, you should have a latency of under 50 milliseconds. You definitely need a latency of under 100 milliseconds. So again, this is a way you can naturally ask questions. So like, look, I'm having a problem with Skype today. Why am I having a problem with Skype? If you create the system, all this information can just be in basically a log file, and then you can ask natural questions, or your users can ask natural questions, right? And so this kind of gives you an idea of how you can try to start bringing some of this operating system level stuff into your AI projects to start helping people out. Again, one of the big things I talk about, like back when, so I had my own company, so new people, I had my own company, I had 9 employees back in the day. One of the things I really believed in was education. Like I could either sit here and like build some security system for 5 days for users that they were gonna probably break in a couple hours, or I could just sit down and talk with them for a little while, and that normally solved the problem. And so again, something to be thinking about here is, again, like with these services, can you create a backend service to continually collect information about the network, about devices or whatever, and then when your users have a problem, can you then, like using Bottle, so I've taught you guys how to use Bottle, create a web application so your users can just simply ask a question. Like, hey, I'm having a problem with Salesforce, is there a reason? And it comes back and it says, yes, there is a reason, the latency is really high. Would you like to file a work order with the help desk? Yes. Or nope, there's not a problem with Salesforce.com, you're screwing things up again, bugger off, you know, whatever else. Say it in a polite way, say it in a polite way. Let's see here. Yeah, that's about it. And at the end, there's a little lab for installing Ubuntu, but I actually showed that to you in the beginning. So that is the class for Linux tonight. Any questions? No? What's that?
Like, will this be available online?
Yeah, so it's, well, you can take that too, but yeah, it's on GitHub. Okay. So if you go to Silicon Dojo, let's see here, where's my Safari? If you go to, should be these. So if we go to Silicon Dojo and you click on GitHub, that should take you to GitHub. And then yeah, so, oh, what the hell? That is the wrong GitHub thing. Anyways, so if you go to, so you go and then you go to Silicon Dojo and you look for the in-person classes, repository, in-person. So one, I will fix that link, but also if you go to the meetup page, if you go to the meetup page for this particular class, every time before we do the class, I'll always put a link to the workbook and code. So that's there, and that'll take you there too.